Welcome to this video on high-level data link control or HDLC. HDLC is a bit-oriented data link layer protocol developed by ISO for reliable communication between network devices. It provides framing, error detection, and flow control, ensuring accurate data transfer over both point-to-point and multi-point links. HDLC supports both half-duplex and full-duplex communication and uses control frames to manage the flow and acknowledgement of data. HDLC is a reliable bit-oriented protocol that ensures efficient and accurate data transfer. It supports selective repeat or go back in ARQ for error handling and provides full duplex communication, allowing transmission and reception simultaneously. Being bit-oriented, HDLC uses bit stuffing to handle flag patterns in data. It also includes flow control, adjusting the window size according to the receiver's capacity, and relies on physical layer clocking and synchronization for sending and receiving frames effectively. HLC defines three types of stations: primary, secondary, and combined. The primary station controls the communication process. The secondary station responds to the primary's commands, and the combined station can act as both primary and secondary. It also supports three data transfer modes: normal response mode, where the secondary transmits only when permitted by the primary; asynchronous response mode, where the secondary can transmit without explicit permission; and asynchronous balanced mode, where both stations have equal status and can initiate. Additionally, HLC uses three types of frames: information frames for data transmission, supervisory frames for flow and error control, and unnumbered frames for control and link management to ensure reliable and efficient communication. HLC define three types of stations: primary, secondary, and combined. The primary station controls the operation of data flow on the link and is responsible for error recovery. Frames sent by the primary station are known as commands. The secondary station operates under the control of primary station and sends frames known as responses. The primary station maintains a separate logical link with each secondary station. In the third category, the combined station functions as both a primary and a secondary, meaning it can send and receive data independently without relying on another station for communication. HDLC supports three modes of data transfer operations: normal response mode, asynchronous response mode, and asynchronous balanced mode. In normal response mode, mainly used in terminal mainframe networks, secondary stations can only transmit when specifically instructed by the primary station in response to a polling command. This unbalanced configuration is well suited for multi-point links. In asynchronous response mode, the operation is similar to NRM except that secondary station can initiate transmissions without direct polling from the primary station. This reduces communication overhead since no extra frames are needed to permit secondary transmissions, making it more efficient for point-to-point links. In asynchronous balanced mode, used primarily in point-to-point communication, both station access combined station and can transmit data independently, providing a balanced and flexible communication setup. HDLC uses three different classes of frames for communication: unnumbered frames, information frames, and supervisory frames. Unnumbered frames are used during link setup configuration and disconnection, and they do not contain acknowledgement information. Information frames carry the actual data or user information between stations, and in the case of asynchronous balanced mode can include a piggyback acknowledgement for received frames. Supervisory frames are primarily used for error detection and flow control. They contain send and receive sequence numbers to manage and ensure reliable data transmission. The HDLC frame structure defines how data is organized for reliable communication. Each frame begins and ends with a flag field used for framing, followed by an address field that identifies the destination station, a control field containing control information, a variable length information field that carries user data, and an FCS for error detection. The control field format varies by frame type. Information frames are used for data transfer and include send and receive sequence numbers with a pole final bit. Supervisory frames handle error and flow control with the supervisory function bits and sequence numbers. And unnumbered frames manage link setup, disconnection, and control using unnumbered function bits. Together, these fields enable efficient and reliable data transmission under HDLC. The HDLC frame structure can include extended fields for large addressing and control capabilities. The extended address field allows multiple bytes to represent addresses, where each byte's least significant bit indicates whether another byte follows. This enables support for more devices on the same network. The extended control field expands the control field to 16 bits, allowing for a large sequence number space. In this format, information frames include the sequence numbers, the pole or final bit, and the receive sequence numbers. Supervisory frames use control bits for flow and error control along with a pole and final bit, and these extensions enhance HDLC's scalability, efficiency, and reliability for complex communication systems.